Hello and welcome to the C++ Insights YouTube channel. I'm Andreas. I work as a C++ trainer offering classes worldwide, on-site or remote. This is my YouTube channel where I use my tool C++ Insights to teach you various topics related to C++. Welcome back to the channel. Today I like to talk about a C++26 feature, and this is pack expansions, which brings a whole new way how we can use variadic templates. And today I'm going to show you an example using variadic function templates. So let's dive into that. What do we have here? So this time it might be best to start from the bottom and work our way up to the top. So what I'm trying to write is a function called add. So more precisely a function template, because I want to be able to use it with as many parameters as I have, even if it doesn't make that much sense for my implementation here. I'm also willing to be able to call add with a single parameter. Okay, so this is what we're trying to build. Now this here is the implementation of add. As you can see, the template had its standard variadic function template. The function name is add, and here we have the variadic arguments. I take them all by constexpr because I'm not intending to forward them or do anything special here. Internally, I'm using C++17's fold expression to sum up everything and get away with all the recursion here doing the job. You can see I squeezed in some C++20 code as well. So here we have a requires clause, and the requires clause ensures that all arguments in this parameter pack args here are of the same type. So this brings us to my first helper here. The first helper is rsamv, and we find that here at the top of the file, rsamv is a variadic variable template. It takes a type name t and a pack here in with the name args. The name is rsamv. It's a constexpr bool variable. You should make it inline in your real-world code base if you share it in a header, but here I don't, so that one is fine. Then I'm using issamv here for t and args, and that thing together and let it expand for every value in the parameter pack, ensuring that all the arguments in the parameter pack are equivalent to t, are the same of t, and so this is how I decide whether all the arguments are the same. So this is this part. And the second thing I now want to do is add should return the first type in the parameter pack, right? They're all the same, so if I pick the first one, it's as good as picking the last one or anything in between, but I always have one, so I can rely on that first one. I don't use auto here. I don't want the compiler to spend extra effort figuring out the return type, because we know it at compile time when we write this function template over and we invoke it. So no need to figure out in the function body what's actually returned. We know it from the template head. So my first arg t here is my second helper. That one requires a few more lines of code. We start here. I have this struct first arg t. It takes a type name t and the parameter pack. Here you can see I don't care about the name of this pack because I'm not going to use it. All I do is I extract the first parameter, put it into the struct under the name type using a using declaration here and letting it point to t. To make things nicely usable in the rest of my code base, I then add another using alias first arg t. That one takes just a argument pack, and I use the type name here to spare it in all the other places and let it point to my first arg struct, extracting the type here. So this is basically extracting the first type of this argument pack. With that code written, I can use it here, and that spares me the auto. Why do you want to spare the auto? Well, there's a blog post coming up where I talk more about that. So for now, just let's say I want to save compile times, and I know the type up front, so let's not bother trying to use the compiler figuring out. So this example here works. I can demonstrate it, I can compile it, you can see it works. The C++ insights here shows us the various instantiations, which are currently not that interesting. What I want to focus on is all that code I have to write here to, at least that one here, to grab the first type of a parameter pack. This is a recurring question during my training classes. Frequently comes up that people say, hey, I want to access the first type, the last type, something in the middle, like with an array, I can do this. Why can't I do it here? The simple reason is because the standard says so. With C++26, the standard changed its answer. So with the same question you are asking, you will now get a different answer when you're in one of my training classes. This is what I prepared here. So you can see, first of all, the original code here. I used 27 lines of code to achieve my goal. And here I only require 17. As you can see, I missed one of the adds, so technically it's 18. But that's in the range of 10 lines less, which is a good thing because I always prefer getting things done with as less code as possible. So what we are looking at here. So our same way is unchanged. That's the same as before. So is my template head here. That one takes the argument pack, pushes it in the requires, checking that all the arguments in the pack are the same. And now we can see this piece here is new. And this is a pack expansion where I really now can access the individual elements like for an array. Of course, I have to know the size, so if I go out of bounds, it doesn't compile, so it might be even a better thing than with a regular array. But here I can say I have my argument pack args. You see the ellipsis here hinting to the compiler that we are talking about the argument pack. And then I say, okay, I want to get the type, because this is my argument pack here, the type at position 0, and this then yields my return type. So I can get rid of what I had previously here, this entire implementation of first argt. That's all now abstracted in here. If we translate that or transform it with C++ insights, we can see it simply yields to int because the entire pack here is full of integers. Less code to achieve this goal here. I think it's a great improvement to the language. Let's say you want to spare your users having to know this syntax here. If you want to spend a little more code, we can still come up with something like this here and use a using alias as before. Okay, and then we say the dot 0 here. If you prefer this version, then this is yielding the equivalent transformation. So in this case, C++ Insights preserves you the using alias. It would work the same way. So if you want to make things easier for your users and not having to know or understand this new pack expansion syntax, then you can still do that. So you can cut off a few lines of code. That also is positive for your compile times, because in the initial example here, for the compiler generating the struct, it's a great amount of effort. So if you are having a significantly large code base, that could bring up your compile times, while the using alias typically is in the books of being cheap. This would here be the faster version, and the initial version I presented you where I directly used the pack expansion, that's the one where you have basically the best speed, but that one would be a good middle way between speed and readability and easy usage for your users. So I hope this new C++26 feature helps you improving your compile time, speeds, doing new things, and indexing into parameter packs or argument packs. And you will see it helps a lot to implement stuff with less lines of code that required way more code before. So check it out and enjoy C++26. That's it for today. Thanks for watching.